The new digital SAT is, I think, infamous now for the difficulty of the final questions of each module, especially in the math module 2. And this question probably is on the level, I think, of that difficulty. So if you're having trouble with some of those really hard questions, this is a good one to practice. So if you haven't tried this on your own first, very strongly recommend that you give it a shot before you watch the solution. Part of what makes this question so challenging is obviously it's a long word problem. There's a lot of information presented in the body of the problem itself that we need to organize. The first thing I want to point out, whenever you see a question on the SAT involving distance, speed, and time, this formula will very likely come in handy. D is equal to RT, where D is the distance traveled, R is the speed or the rate, and T is the time. And we're going to make use of that in this question. Next point, again, we want to read this text and organize this information in a way that will help us at least figure out what a good next step might be. And here, on these kind of distance, speed, and time problems, I like to draw a picture as a way to organize this. So we have a car traveling at x feet per second. So here's my car. And it's traveling at x feet per second. We'll do it like this. X feet per second. Driver sees a red light ahead. So here's our red light. Now, obviously, on the real test, you would have to do this all in your pencil, but just for sake of teaching this, I'm going to use some colors just to make it a little bit easier. But at this point, they see a red light, and then after 1.5 seconds, they apply the brake. So if at this moment they see the red light, then 1.5 seconds later, they apply the brake. So here they apply the brake, and this was 1.5 seconds of delay. After the brake is applied, the car takes x over 24 seconds to stop, during which time the average speed of the car is x over 2. So I'm going to sort of draw a longer line here. This is where the car is going to stop. And we know that the amount of time it took for the car to stop was x over 24 seconds. And we know the distance or the speed of the car, the average speed of the car over this interval, over this stopping period, was x over 2 feet per second. The car travels 165 feet from the time the driver saw the red light to the time it comes to a complete stop, which the following equations can be used to find the value of x. So basically, this distance traveled is 165 feet. So you might be tempted, and it's not a bad idea in many questions, to look at the choices, look at those expressions, look at those equations, and try to figure out, well, okay, the 48 and the 72, can I figure out from this scenario which one of those might be right or what those might mean? Same thing with those big numbers, 3,960, 7,920. Can I look at those and work out where those are coming from and therefore which equation might be right? And a lot of times that is helpful because you can essentially reverse engineer the equation and from that figure out what fits with what the problem is saying. This is one of those rare cases where it's actually not helpful at all. I don't think you can actually look at these choices and make much sense of them. If you have a way that you think they make sense, just based on what we know now, let me know. But otherwise, I think we have to actually create the equation ourselves. And this is where we're going to use D equals RT, because we essentially have two legs of our trip, essentially, right? We've got this leg of our trip, and we've got this leg of our trip. And one thing I actually want to add here, because it's a little sneaky, is the speed in this interval is still x feet per second, right? Because they see the red light, but then before they hit the brake, there's this delay. So they haven't lost any speed yet. It's only when they hit the brake they're going to start to lose the speed. So what we can do is we can look at each leg of this trip, if you want to call it that, and determine what was the distance traveled for each of these legs using our equation. So D is equal to RT. So for the first leg of our trip, distance is what we're trying to find. The speed is x, so I'm just going to put that in for r, and then the time is 1.5 seconds. So now we know that the distance traveled in terms of x for this little pre-braking part of the trip was 1.5x. And we do the same thing for the second part of the trip because we know the speed traveled is x over 2 feet per second, and that happens for x over 24 seconds. So if I multiply these together, I'm going to get x squared over 48. And now suddenly, we're beginning to see something that looks kind of familiar. Now, of course, we're not done yet, but that's a good starting point. Now, what do we do? Well, the key is I want to create an equation out of this. This distance plus this distance must add up to the total distance we were told. So we can go ahead and create an equation here by adding up 1.5x plus this x squared over 48, and that must equal 165. That's our total distance traveled. So now, again, now we're starting to get something that looks like a quadratic. Let's move that 65 over. So we have 0 on the left side or on the right side. So we'll get something like this. We subtract 165 from both sides. Want to clean this up? Let's multiply through by 48. And I'm going to pick this up over here, I guess. So when I multiply both sides by 48, the 48 under the x squared cancels. 1.5 times 48 is 72. And so now, actually, we can get rid of a and b. And then I just need to do 165 times 48. We get 7,920, and it's minus. So there it is. That's our equation, and that matches choice D. So to sum up how we tackled this question and really how we tackle hard questions in general in the SAT, the question is going to be hard very often because it is not going to be obvious at first glance what you're supposed to do, right? It's not clear looking at this, oh, I do this step and this step and this step and I'm done. That's what makes it hard. So we need to figure out what to do, or at least what the next step might be. So step one, sort of recognize what kind of problem it is. In this case, distance, speed, and time. What equations, what tools, what facts can be useful potentially. In this case, D equals RT. Second, if it's a word problem, as you read it, organize the information, write it down, do your thinking on paper. Don't try to keep it all in your head. If possible, draw a picture, or otherwise just write down the information. Even if you're just copying the information down in your own handwriting, that will make a difference to help you to begin to process it. And then at that point, it's just the magic of figuring out what is the next step. Not what do I have to do, A, B, C, D, E, F, G to get to my answer, but what's step A or step one? Like once I've written this down, what's the next thing I can figure out? And then you may not know after that first step where you're going to the next step, but look for just the next viable step. And over time, you'll make your way through the kind of fog of war of the question, and you'll eventually see the light at the end of the tunnel, to mix metaphors a little bit. But anyway, go ahead, work your way through. Just know you're going to have to deal with that discomfort of maybe not knowing exactly where you're going. But if you're methodical and you're careful, you write stuff down, you try to find that next step, you'll figure it out.